Hello everyone. Welcome to Brain Blitz Audios. In this episode of NEET preparation, we'll be looking at previous year questions of chemistry in medical entrance examinations in India. The chapter that we'll be dealing with is the first chapter in the grade 11 syllabus for chemistry in CBSE. The name of the chapter, Some Basic Concepts of Chemistry. So let's jump into our first question. The vapor density of a mixture containing NO2 and N2O4 is 27.6. The mole fraction of NO2 in the mixture is. How do we start doing this question? Any ideas? Well, here's one. Let's define vapor density first. So the vapor density is defined as the density of vapors of an element with respect to that of hydrogen. So vapor density is the density of vapors of an element with respect to that of hydrogen. And it can be calculated as vapor density is equal to mass of n molecules of gas divided by the mass of n molecules of hydrogen. Now, we can also write vapor density in terms of molecular mass. So molecular mass can be written as 2 times vapor density. So vapor density will be equal to molecular mass divided by 2. So this is about vapor density. And the other formula that you should be remembering, that the main formula that we'll be using here is max vapor density, that is the vapor density of the total solution, will be equal to XA plus XA times vapor density of A plus XB times vapor density of B, and so on. So in order to find the maximum vapor density, we need to multiply the mole fraction to the vapor density. So now, over here, we're not given the the vapor density of NO2 or N2O4, but we can calculate their molecular mass. So over here, we'll write the vapor density of NO2 as, so N has 14 plus 16 plus 16 because there's 2O divided by 2. So that will be 46 divided by 2, which will be equal to 28. So the vapor density of NO2 is 28. And the vapor density of N2O4 will be equal to 14 plus 14 plus 4 times 16 divided by 2. Now that will be equal to 92 divided by 2, which will be equal to 46. So the vapor density of N2O4 is 46. Now, let's consider the mole fraction of NO2 as X, and therefore the mole fraction of N2O4 will be equal to 1 minus X because the sum of the mole fractions has to be 1. So the vapor density of the solution, which is given as 27.6, will be equal to X times 23 plus 1 minus X times 46. So we have 23X plus 46 minus 46X will be equal to the vapor density being 27.6. So let's write the total as 27.6. So on calculating, we'll get 27.6 as 46 minus 23x, because 46 minus 23 is 23, so it'll be 46 minus 23x. Now let's change terms. So we'll write 23x as 46 minus 27.6. So we'll just do it here. 460 minus 276. 10 minus 6 is 4. So it will be 15 minus 7 is 8. 3 minus 2 is 1. So it'll be 18.4. 23x is equal to 18.4. So the mole fraction x, which is the mole fraction of NO2, will be equal to 18.4 divided by 23. And on multiplying 23 times 8, you'll get 3 times 8 is 24, 2 times 8 is 16, 16 plus 2 is 18, you'll get 184. So 184 times 8, no, 184 divided by 8 gives you 23. So 18.4 divided by 0.8 will give you 23. So the mole fraction of NO2 is 0.8. And if you look at our options, you find that option A, 0.8, is the right answer on calculating. Let's look at our next question. An aqueous solution of 6.3 grams of oxalic acid is made up of 250 ml. The volume of 0.1 normal NaOH required to completely neutralize 10 ml of this solution is. So, how do you calculate this question? So here we are given the normality of NaOH, but we don't know the normality of oxalic acid. So we need to find the normality of oxalic acid, and normality can be calculated as given weight divided by molar weight into volume of the solution in liters. So here given weight is 6.3 divided by molar weight of oxalic acid is 63 times 250 ml. So it'll be by 1,000. So that goes to the top. So it'll be 6.3 into 1,000 divided by 63 into 250. So basically 63 by 63 into 100 divided by 250. And so you can cancel the 0, and 10 and 5 goes into 10 2 times, and 5 goes into 5 5 times. So that will be 2 by 5, which will be equal to 0.4. So the normality of oxalic acid is 0.4 N. So now we have the normality of NaOH and the normality of oxalic acid. So we need to neutralize this solution. How do you do it? For neutralization, N1V1 is equal to N2V2. So the product of normality and volume of the first solution will be equal to the product of normality and volume in the second solution. So N1 is for, so this is for oxalic acid, and this is for NaOH, the right side. So in the left side, we have 0.4, that's the normality, times 10 ml. So that's given here to completely neutralize 10 ml of oxalic acid. So 10 ml will be equal to N2, so that is the normality of NaOH, that's 0.1, times V2, which we need to find out. So let's consider it as V. So 0.1 V is equal to 0.4 times 10, which is 4. So therefore, the volume can be calculated as 4 divided by 0.1, which on taking the decimal on both sides, so we just multiply by 10 on both numerator and the denominator, we'll get 40 by 1, which is equal to 40 milliliters. And on viewing our question, we find that option B is the right answer. 40 mLs of NaOH, which is 0.1 normal, is required to completely neutralize 10 ml of 0.4 normal oxalic acid. Now, towards the next question. Calculate the normality of 10 volumes H2O2. So the general formula for normality will be number of gram equivalents of one solution divided by its volume in liters. And over here, we're given 10 volumes, so we can directly put that. But how do you find gram equivalents? Gram equivalents are molar weight divided by n factor. And this n factor is equal to the valency. So volume in liters. So here we have H2O2. This can be written as 2H plus O22 minus. Because there are two hydrogens, so that gives you +2 charge. So both the oxygens together should have a -2 charge. So that's how you do it. And so therefore we can get the n factor as 2. And the molar weight of H2O2 can be easily calculated. 16 plus 16 plus 2 plus 2. So that's 32 plus 2, 34. So it's 34 divided by 2, whole divided by the volume is 10. That is 17 by 10, which is equal to 1.7 normal. So the normality of 10 volume H2O2 is 1.7 normal. That is option A. Now, the next question. Which of these has the maximum number of molecules among the following? Is it 44 grams CO2, 48 grams O3, 8 grams H2, or 64 grams SO2? Let's look at each of our options one by one. So in order to find the maximum number of molecules, we just need to divide each of our options by the molar mass of the compound. So that way we'll get the number of moles, and on comparing that, we can find out which of these has the maximum number of molecules. So let's do it. So C plus O2 gives you CO2. So that is 12 plus 32 gives you 44 grams of CO2. So 1 mole of CO2 has 44 grams. So now we divide the given mass divided by molar mass. So given mass divided by molar mass gives you number of moles. And over here, the given mass is 44 grams. That is option 1 divided by 44. So that gives you 1 moles. Okay, and so that is basically 6.02 into 10 raised to 23 molecules. Let's look at our next option, 48 grams O3. So O3, there is 3 oxygens. So 3 oxygen basically means 3 times 16, and that is 48. So therefore, the molar mass is also 48, and the given mass is also 48. So the number of moles is given mass, that is 48, divided by molar mass, that is 48, which is equal to, again, 1 mole. So that is 6.02 into 10 raised to 23 molecules. So let's look at our next option. So hydrogen has an atomic mass 1. So H2 will have a molecular mass 2. And the question is given, we have 8 grams of hydrogen gas. So therefore, the number of moles will be equal to given mass 8 divided by molar mass 2. So that is 4 moles, which is equal to 4 times 6.02 into 10 raised to 23. So it will be 24.08 into 10 raised to 23, which in significant terms we can write as 2.408 into 10 raised to 24. So therefore, we find that H2 has a lot more molecules. That is option C. Let's look at option D just to confirm. So again, 64 grams of SO2, and SO2 is 32 plus 2 times 16, that is 32, so that gives you 64. So the given mass is 64. So the number of moles is equal to 64 by 64, which is equal to 1 mole. 1 mole is equal to 6.02 into 10 raised to 23. So therefore, we can find that option C, 2.408 into 10 raised to 24, is the highest number of molecules among the given options. So therefore, option C, 8 grams hydrogen gas, is the right answer. So 8 grams hydrogen gas has the maximum number of molecules among the given options. So here we have our next question. Sulfur forms the chlorides S2Cl2 and SCl2. The equivalent mass of sulfur in SCl2 is 8 grams per mole, 16 grams per mole, 64.8 grams per mole, 32 grams per mole. How do you calculate? So equivalent mass is equal to the atomic weight divided by the valency. So here we have to find the equivalent mass of sulfur in SCl2. So SCl2 becomes S2 plus Cl2Cl minus. So S has the atomic weight 32, sulfur, and divided by its valency is 2. So we have our answer 16 grams per mole. Option B is the right answer. Now we have our final question. Arrange the following in the order of increasing mass. And here we're given the atomic mass of oxygen, copper, and nitrogen for our reference. So the first thing that we have is 1 atom of oxygen. So to calculate the mass of 1 atom of oxygen, we will divide the molar mass by the number of molecules in 1 mole, basically the Avogadro's number. So it'll be 16 divided by 6.02 into 10 raised to 23. So 16 by 6.02 will give you an approximate answer of 2.66 into 10 raised to minus 23, since it was earlier in the denominator. So 2.66 into 10 raised to minus 23. So now let's look at our second one, mass of 1 atom of nitrogen. So we have the atomic weight of nitrogen is 14 divided by Avogadro's number, that's 6.02 into 10 raised to 23. So here we can calculate 14 by 6.02 as approximately 2.32 into 10 raised to minus 23. And number 3, we have to find out the mass of 1 into 10 raised to minus 10 moles of Cu, or of oxygen. So if you remember, 1 mole of oxygen weighs 16 grams. So 1 into 10 raised to minus 10 moles of oxygen will weigh 16 into 10 raised to minus 10 grams. And option 4, again, copper. So 1 mole of Cu would weigh 63 grams. And here, because that's given in the question, copper's atomic weight is 63 and the molar weight is basically atomic weight in grams. So 1 mole of Cu has 63 grams. So 1 into 10 raised to minus 10 moles of Cu would have 63 into 10 raised to minus 10 grams. So if you notice, we find that in options 1 and 2, we have the same order, 10 raised to minus 23. But we find that 2.32 is lesser than 2.66. So therefore, we can write 2 is less than 1. And since in 3 and 4, we have the same order, 10 raised to minus 10, and 63 is greater than 16, we can also write that 3 is less than 4. Now, if you compare the orders for 1, 2, and 3, 4, you would find that 10 raised to minus 10 would be greater than 10 raised to minus 23 because it is 1 by 10 raised to 10 and 1 by 10 raised to 23. And so the one with the greater denominator would be lesser. So therefore 10 raised to minus 10 is greater than 10 raised to minus 23. So the correct order will be 2, less than 1, less than 3, less than 4. And where do we see this order? The order is found in option A. So option A is the right answer. So this is all from this episode of NEET preparation. So we have a host of other videos about the same chapter. I'll provide you the link in the description down below. We also have a whole playlist of NEET preparation videos. So we'll put that in the description below as well. So please don't forget to click on the link in our description down below. Also, Brain Blitz Audios is a YouTube channel which provides free educational content to all. To be a part of our journey, please subscribe to our channel and please look out for more of our educational videos. So until the next episode, take care, stay safe. Bye-bye for now.